Welcome, geometry students, to a Kuta worksheet tutorial. We're doing similar polygons. Let's go ahead and get right down into it. State if the polygons are similar. Okay, so we have to have two polygons in order to determine if they are similar. And what are we trying to decide here? Well, similar means that they have congruent angles, okay, and proportional sides. Or side lengths, I should say. Okay, so they have the proportional side lengths. Now, what does that mean? Well, it means that if we have this top side, this short side, okay, well, time out, let's rewind. We have to have all the same angles. So you can see, number one, we've checked all the angles are good. Okay, we're going to check that box. Let me make the box first. Okay, that's going to be better. Okay, so first thing we have is all angles are congruent. Check. Okay, now we need to know, are the sides proportional? So we're going to take this short side and compare it to this short side. So we need to know, is the short side of the small one, so we're comparing the small rectangle to the big rectangle, is the small one, the short side compared to the short side, the same as the long side? Okay, let's go to the blue one this time. The long side compared to the long side. Not sure why this. There we go. Okay, so is it the same ratio? The long side divided by the long side. Okay, let's take a look at our numbers. So we have 10 to 15. Okay, that's the short side of the small rectangle divided by the short side of the big rectangle. Is that equal to 14 over 21? So what you need to do here is you have to reduce each one of these fractions. So let's go ahead and reduce. We can divide both of these by 5. So we're going to divide both by 5, top and bottom, divide by 5, and we get 2 over 3. We can divide this one. They have a common factor of 7, so we're going to divide this by 7. Divide this by 7, and we get 2 over 3. So guess what? These are proportionate sides. So this one is similar. So yes, for number 1. Okay, and that's what you're going to do for each one of these. Okay, so what we're going to do is we can identify the number 1. All the angles are congruent for both of these ones. Okay, all 90 degrees. So now we're going to compare side to side. So I'm doing the short side first this time. I should probably be consistent. Let's use purple for short side. Okay, so short side, we have, let's do small over big. So 18 over 24. Okay, so this is the small one. This is the big one. Okay, small, and this is the big. This is trying to trick you by just change the position, but you just have to stick to your guns. Okay, so we have 16 and 24. So is this equal to 24 over 36. All right, that's the question at hand. So we need to, again, divide this out and see if it's proportionate. So we can divide both of those by 6. We get 3 over 4. We can divide both of these by 6, and we get 4 over 6. Actually, we could have divided by 8, couldn't we? No, 12. So we divide the top one by 12. We get 2. And then 3. Okay, so this one is not proportionate. Notice how we had a 3 to 4 ratio of the small one to big one for the short side, but then a 2 to 3 ratio for the long side. So this one is not proportionate. This one is not similar. Okay, so that's how you go about this exercise. And you can do that with all of these. So for number 3, we need to figure out these angles. So I'm guessing this is the 40-degree angle. Okay, and that would make this one, because it's a parallelogram, supplementary. So this would have to be 180 minus 40. So this is going to be 140 degrees. If that's 140 degrees, we already know it's not similar because that is 130 degrees. All the angles have to be similar. So this one doesn't even pass the first test, not similar. Okay, so what we can do here is we can just kind of copy and paste this each time. Okay, copy, and just bring this with us. Paste. So for this one, it did not meet the first qualification, and all it needs it to do is not pass one of them, and it's not similar. Okay, this one looks good so far. If this is 100, that's got to make this 80. If this is 100, that's got to make this 80. Okay, and now we just need to figure out the proportions for the sides. So we have 24 over 20. Okay, we can go big to small. So this time, let's go big to small. So we have 24 over 20. And then we're going to go over here and compare our other side. Okay, 48 to 40. Okay, as long as you're consistent with this, you're fine. You can actually do this. So for the first one, we can divide both by, let's see, 2. We get 12, or no, we can divide by 4. And we get 6 over 5. Can we divide, what can we divide this one by? 8, I think. So we can divide the top one by 8. We get 6. And okay, so guess what? This one is similar because the angles is a check. Check for angles. Check for sides. So this one is similar. Okay, so we are good to go on that one. And that's what you're going to do for all these exercises. Okay. You're gonna set these ratios up. Okay, so this one has the angles, so we just need to compare the sides. So we have 35. You might need to rotate this one. So this one looks like, oh, I'd compare this 35 to this 18. No, I need to compare it to the longest side. Okay, longest side of the big one over the longest side of the small one. So I'm going to do 35 over 21, and then I'm going to go to the small side. Okay, let's go green. That doesn't matter. And then I'm going to go 30 over 18. So 30 over 18. And then I'm going to reduce and see what I get. Okay, so I'm going to reduce this. I can divide this one by, can I divide this one? 7. I can divide the top and bottom by 7. And I get 5 over 3. And I can divide this one by 3. And I'm going to get 10 over, no, I can divide by 6, can't I? I'm going to divide by 6, and I get 5 over 3. Oops, not 6, sorry. I can get 5 over 3. So this one actually is similar. It probably is a little trap for you. You may have made a mistake the first time around. Okay, so now we're on to the second part. This is equally important. State the scale factor of each one of these. So we have here that they are similar. So we know that these two triangles are similar. That's our little symbol for similar right here. Okay, so now we just need to say, okay, what's our scale factor? Now, we see here that this is the biggest side, so we need to compare these ones. So we do 40 divided by 16. I always like doing, for scale factor, I like doing the big divided by the small. That makes it, I think that makes it easier. So we can just go either reduce this, so divide by the biggest number, biggest factor for both these, greatest common factor. So we can divide by 8, and we get 5 over 2. Okay, or you can just do 40 divided by 16 on your calculator, and you get 2.5. Okay, so both of these are considered the scale factor. This just means it's a 5 to 2 ratio, or 2.5 times bigger. All these numbers for the small one, multiply times 2.5 to get the bigger one. So 14 times 2.5 gives you 35. 16 times 2.5 gives you 40. Okay, so that's how a scale factor works. Okay, so this one, we're going to compare the smallest side to the smallest side, or the biggest side to the biggest side. You should get the same thing if they are similar. So we're just going to do 15 over 10. That one's a little bit easier. And we get, divided by 5 to both, we get 3 over 2. Okay, so 3 over 2 would be our scale factor, or 1.5. Both of those are okay. And that's all there is to it. Some of these are maybe a little bit more tough to identify which sides you have to compare. Obviously, it's going to be 25 over 5 here, so that's going to be a scale factor of 5. This one, you can use any of the numbers, 42 over 35, and just reduce it into a fraction. I'm guessing it's looking for fractions here. Let's see if there's any other tough ones. Okay, this one, this is the longest side of the big rectangle, so we're 18. The longest side of the small rectangle is 6, so this is going to be 3, or 3 to 1. And then this one, we choose the biggest side here, so 14 over 8, or 12 over 7. Okay, so 14 over 8, 14 divided by 8, we get 1.75. That's interesting. Okay, so 12 over 7, something's wrong with this one. So This 7 does not correspond to this side. Okay, what I'm guessing here is you can only base it off the information it gives. So we're going to go with a 1.75 ratio here on this one. This one's kind of a little tricky. I'm not a big fan of this one. Okay, so 8 times 1.75 gives you that side. 7 times 1.75 needs to give you this one. So 7 times 1.75 equals 12.25. So that's like a missing side there. And then we can go in reverse and say 12 divided by 1.75 to get this missing side here. So 12 divided by 1.75 equals 6.857. Okay, so something ugly. But this one's kind of a weird one. Not a big fan of 18. I think they were trying, but maybe trying a little bit too hard. So don't worry about that one, but all these other ones are fairly straightforward. That is a good introduction to similar polygons and scale factor. Hope you enjoyed this video. Join me next time on Wes Explains Best.